In this video, AP Statistics, we are going to be in Unit 2 and we're looking at Example 4. Make sure that you pause the video and read what is happening so you're not left clueless. All right, so in this particular situation, we have our scatter plot over here, and we've already been given the regression line, and we've also got some data here for miles driven and the price of Ford F-150s. So as you can see, there's a negative relationship here because as my explanatory values increase, my response variables are decreasing. Okay, so if we write the regression equation in context, it just means I'm writing this right here using the variables for y and x. So y is price and miles driven is x, so I'm writing price with my prediction symbol right here. This is my y-intercept, this is my slope, and then of course miles driven would be right here. I probably should have written miles driven there. So let's change that. Miles driven. There you go. All right. So now we're being asked to predict the price of a Ford F-150 with 90,000 miles. So I'm going to use my regression equation, and I am going to replace miles driven with how many miles are driven, 90,000. Put that in my calculator. This is what I get. Remember that a prediction equation is not for sure, okay? It is not the end-all be-all of your answers. So I do have about over here. You can also write your answer this way. This shows that you mean it is approximately 23,596. Always a good idea because this is not perfect. All right, now on part C, we're predicting the price of a Ford for 200,000 miles. So then I get an answer here once I substitute that in. So why are we doing this? Well, if you'll notice in part D, I'm asking you how confident you are in each of these predictions. Well, I want you to notice the domain of my scatter plot. So this is my domain right here, right? And technically, all of these miles driven in my data, those are all my domain. Well, if you'll notice, my domain does not go past 160 on my graph. And technically, this point right here is as high as my domain is going to be. And it looks like that is at 144,162. So anything lying outside that domain too far is going to be something I really don't trust because that's going to be an example of extrapolation. Remember, extrapolation happens anytime I make a prediction too far outside the domain or the x values of my data. So when I answer this, I'm pretty confident that 90,000 is an okay prediction because 90,000 is occurring right here, well within the domain of my miles driven. So I'm not too worried about 90,000. 200,000 on the other hand is going to be out here outside my domain. So I'm worried that this is going to be extrapolation. So that prediction might not be as reliable as I'm hoping. Okay, for part E, Ford F-150 that has 70,583 miles was priced at 21,994. Okay, so this is an actual data point. Okay, so this is an actual value, but we're being asked to calculate and interpret the residual for this vehicle. That means we have to find the predicted Y because remember, a residual is the actual Y minus the predicted Y. So this is my actual ordered pair right here. So I'm going to take 70,583 miles and I'm going to substitute it into my equation so that I can get the predicted Y. Now to find my residual, I take my actual price and I subtract from it my predicted price, and that gives me a negative 4,765. It is perfectly acceptable to get a negative value for your residual because it clearly tells me that my actual data point is lying underneath my line. My line is under predicting my line is over predicting the actual value. So notice that since my actual price is $4,765 below the predicted price, it means our equation is actually over predicting in this particular situation. All right. The next thing we're going to do is interpret the slope. This is really important because when we're interpreting our regression line, our slope and our y-intercept go a long way to helping us understand what is actually happening. All right, so when I talk about the slope, in this particular situation, this indicates right here that we have a slope of 0.1629. That means that for every mile driven, I expect the price to decrease by $0.1629. Well, we don't talk about dollars like that. So in order to make this a little bit easier to understand and help it make more sense, rather than talking about 1 unit of miles driven, I'm going to talk about it in 1,000. And that just means that that decimal of 0.162 will now change to 162.9, which $162 makes a little bit more sense to us. So for each additional 1,000 miles driven, I can expect a decrease in price by about $162.90. All right, so if I am looking at this, please keep in mind, interpreting the slope, you need to do it the same way every time. For each additional, whatever this is, using your context, I can expect or predict a decrease. If it's a negative slope, you're going to write decrease. If it's a positive slope, you're going to write increase in price, whatever your response variable is, by about whatever the slope actually is. All right, so that is exactly how you would interpret that. All right, so now let's interpret the y-intercept. Well, the y-intercept is this value in my equation right here. So the y-intercept is going to be the value whenever miles driven is 0. So if I substitute 0 in for miles driven, that means I'm just going to be left with price equals 38,257. So in other words, a Ford F-150 with 0 miles driven is going to be expected to cost about $38,257. Now what you have to answer in this, the question asks you, does this value have meaning in the context of the problem? In other words, does it make sense? Well, if you were getting a Ford F-150, now granted, if you got all the bells and whistles, it wouldn't be that cheap probably, but it's not unreasonable that a new truck would cost you $38,257 because a new truck wouldn't have any miles on it. So this value does have meaning because it is reasonable that it could cost, a new one, it could cost $38,257. Okay, we will address the rest of this example in another video because the video is already too long and it doesn't apply to what we did in class with this example. So we will address the rest of it later.